Hi class, today we will continue on chapter 3, Chemical Bonds and Water, where we will cover subtopics of properties in water and also aqueous solutions. So, the Earth's surface being covered by almost 70% of water, in which water can exist in three common states of matter. The first one is liquid, solid, and also gaseous states. So at room temperature, normally water are colorless with a hint color of blue. They are tasteless and also do not have any smell. Okay, so water usually make up about 55% to 78% of the human body. So water, okay, as we studied last week, consists of partially positive hydrogen here, okay, and also partially negative end of oxygen. So oxygen is slightly negative charge, meanwhile hydrogen is slightly positive charge. So therefore they have a strong polar covalent bond, okay, inside within the water molecule itself between the oxygens and also hydrogen. Here we do have a polar covalent bond, this one, okay, and this one, where um, they are sharing the electrons unequally, unequal number of electrons. Okay, so water will tend to form a hydrogen bond between one water molecule with another water molecule, okay, due to the electronegativity of the oxygens of another water molecule. Okay, so within the water molecule is a polar covalent bonds. Okay, between water molecules is hydrogen bond. So any substances that can dissolve in water are known as hydrophilic. So usually hydrophilic substances composed of either ion or polar molecules. Okay, therefore water molecule they can surround the hydrophilic molecules such as ion and polar molecules on their surface, as you can see here. Okay, um, as you can see here, this one is NaCl, which is the salt. Okay, when they mix with water, what will happen? The water will surround the sodium ion and also the chloride ion, thus making it soluble inside the water. Another one is that hydrophobic molecules. Hydrophobic molecules are contrast with hydrophilic molecules. They are insoluble in water. Okay, they do not like water. Usually these molecules are non-polar molecules such as hydrocarbons and also lipid molecules and also vitamins. Okay, therefore the water, okay, the water are not attracted to these molecules, therefore they have a little tendency to surround them and carry them into a solution, thus making them insoluble in water. Next is properties of water. There are 5 important properties of water that you have to remember. The first one is cohesion and adhesion. The second one is high specific heat capacity. The third one is high heat of vaporization. The fourth one is water expand as it freezes, and also water is a versatile solvent. So what is cohesion and adhesion? Cohesion is a characteristic or property where same molecules they can stick together, such as a cohesion between water molecules and another water molecules due to hydrogen bonding. Okay, as you can see here, water molecule with another water molecule, they can attach to each other or attract to each other due to the cohesion because they are the same molecules. Meanwhile, adhesion is a property where a different molecules are stick together. Example, the water molecule here will attract with the wall of the container over here. Okay, so these two attraction between not similar between is different molecules known as addition. Okay, usually the addition and cohesion, due to this characteristic, plants can bring the water from the roots until goes to the leaf by the cohesion and addition. This one I will explain later, more details. So, the property of water, okay, the property of the addition, okay, will, as you can see in the picture here, it will cause the water to become sticky to the pine needle, thus preventing it from falling off the needles, okay, because this water attract to the pine leaf over here, okay. Therefore, it involves the attractions between different molecules. Meanwhile, the cohesion is seen in the actual water drop. Okay, the water drop will forming a droplet because the water stick together. Okay, due to the cohesion. So the importance of these two properties are for capillary action, in which capillary action is referred to the process where the plant used to pull water up the plant from the ground, and also for important for transpiration process in plant, where the water will be lost from the plant through evaporation process. Okay, let's look here. As you can see over here, okay, root pressure will cause the uptake of water from the soil into the root. Okay, and this one, as you can see here, the water are stick together due to the cohesion. Meanwhile, the water, okay, as you can see over here, they will also attach to the cell wall of the xylem, okay, due to the due to the adhesive behavior. So the cohesion and adhesive behavior in the capillary action will cause the water to be able to be pulled up to the plant from the ground, and then it will go to the transpiration process where the water will be lost from the plants, okay, via evaporations. Next is surface tension. Okay, surface tension is referred to an effect within the surface layer of a liquid that causes the layer to behave as an elastic sheet. Why? Because the water molecules are holding together due to the cohesive behavior. Therefore, they can make up the layer. Okay? So this effect will allow insects such as here the water strider to walk on the water because the water molecules are stick together due to the hydrogen bond. Okay, thus allow the small metal object to float on the surface of water and causes the water to form a droplet also. Okay, so if you want to break the surface layer of the liquid, you will need a very high pressure. Okay, so the importance of surface tension, of course, the first one is for the small insect to walk on the water. Okay, due to their very lightweight, and then also formations of the few drops. Okay, dew drops, as you can see, the surface tensions, okay, will give the spherical shapes of the water drops. Okay, and then next also the beading of water on a wax car, because wax is hydrophobic. Okay, and it does not like water, so it will cause the water also, it will force the water also to produce a bits of water, okay, on the walls of the wax car. Next is high specific heat capacity. So specific heat is defined as the amount of heat that must be absorbed, okay, to change the water temperature by 1 degree Celsius. Okay, so due to its high specific heat, water heats up more slowly than almost of any other compounds and hold its temperatures longer when heat is no longer applied. So these characteristics enable organisms which have a high water content to maintain a relatively constant internal. Okay, that's why when you are feeling hot, normally you will go to take a shower or wash your face. Okay, once you wash your face or you taking a shower, so what will happen? Your body will feel a bit cool down because the water able to absorb. Okay, the water able to absorb the temperature. Okay, or able to absorb the heat to from your body, okay, to change its own temperature by 1 degree Celsius. Okay, by 1 degree Celsius for to lose 1 grams of the substance. Okay, and the importance of high specific heat capacity is that to stabilize the ocean temperature, so it will create a favorable environment for marine life. Okay, so that they won't die due to the high heat. Next is high heat of vaporization. So you have to know vaporization is the transformation of substance from liquid state to a gaseous state. Okay. Therefore, high heat of vaporization is referred to the amount of additional heat to change water from a liquid state into a gaseous state. Okay, so as the liquid evaporates, its remaining surface will cool, and this process known as evaporative cooling. Okay, so evaporative cooling helps to stabilize the temperature in organism and also bodies of water, as you can see here, such as the sweating. As you sweat, okay, the heat energy is transferred from your body to the water, and the water will turn into the gas as it evaporates, and therefore the energy is removed from your body and you are being cool. Okay, cool down. Next is water expand as it freezes. Okay, how does it occur? The molecules are far apart when the temperature is increased and they will take up more space. So the question is that why ice is less dense compared to liquid? Okay, ice are in solid states. Okay, when they are in solid state, what will happen? The water molecules, as you can see here, are far apart from each other, thus make it less dense compared to a liquid state where the water molecules are very close together and makes it more denser make it denser compared to the ice. Okay, so the importance of water expands as it freezes. Of course, the ice cube float for your ice cube float on the surface of your drinks, and also for ice float on the surface of the ocean. Because if all of the ice sank, what will happen? All bodies of water would eventually freeze solid in the winter, and thus killing all the life um, that living in the water. Okay. Next is the last properties of water that you have to know is water is a versatile solvent. So what is mean by solvent? Solvent is a substance that can dissolve a solid. Okay. Solid. Meanwhile, okay, the solid is referred to the substance that being dissolved by a solvent, and a mixture of a solute and a solvent is known as a solution over here. Okay, so why water is a versatile solvent? Water is a versatile solvent due to the polarities of the water molecules, because water molecules have partially negative ends, and also water molecule have a partially positive end. Okay, that makes it attract either to negatively charged molecules or positively charged molecules. So the importance of water as a versatile solvent, the first one is for the cell life. Water acts as a carrier that will distribute all the essential nutrients to the cell, such as mineral, vitamins, and glucose. And also it's very important for our metabolic reactions and also chemical reactions in our body, where water will remove waste product, including the toxic, okay, that the organ cells reject from the body and remove them via the urination process and also excretion process. Next, we will look into the last subtopic, which is aqueous solution. So what is aqueous solution? Aqueous solution is referred to any solution where the solvent is water. So if that solution in which the solvent is not water, it does not being called as the aqueous solution. So hydrogen atoms are shared by two molecules that can shift from one water molecules to another water molecules. So when the water molecules, so this is an example of two water molecules. When the water molecules, okay, lost a proton, the hydrogen lost its hydrogen ion. As you can see here, it lost one of its hydrogen ion, which is the proton. Now it is being called as a hydrogen peroxide, hydrogen ions, okay, or H minus. Meanwhile, if the water molecules, okay, accept another extra proton from this one to here, okay, now the water molecule is known as hydronium ion. Therefore, okay, a hydrogen atom can be shared by these two water molecules. So a simpler way to view the process of is that water molecules can dissociate into hydrogen ion, okay, and a hydroxide ion, okay, hydrogen ion and also hydroxide ion. So in pure water, only one water molecule in every 554 million is dissociated. Okay, and at equilibrium, the concentrations of hydroxide ion and also the hydrogen ion is about 10 to the power of negative 7 molar at 25 degrees Celsius. So because of the hydrogen ion and also hydroxide ion of water are very reactive, meaning to say that the water is easily dissociated, it will cause the changes in their concentration, um, and also it will affect the proteins and other molecules inside the cell. Okay, and adding a certain solute, such as acid and also bases, acid and bases will cause the disruptions of the equilibrium in water and modify the concentrations of hydrogen and also hydrogen ion that dissociated from water. And how to calculate this one? It can be calculated using the pH scales that used to describe how acidic or how basic a solution is. Okay, as you can see here, two water molecules. When this water molecule dissociated, it will form a hydroxide ion and also hydrogen ion that will be accepted by another water molecule over here and thus producing hydronium ion. Okay, remember why it is called by ion? Because they accept or donate the protons, okay, or they donate their proton or electrons. So next, acid and base, the one that will disrupt the equilibrium of water. So an acid is a substance that increases the hydrogen ion concentration in a solution. Therefore, when you add hydrochloric acid into the water, what will happen? Hydrogen ion will dissociate from the chloride ion. Okay, HCl, they will associated becoming the hydrogen ion and also chloride ion. Therefore, the releasing of the hydrogen ion from the hydrochloric acid will cause the water solutions, the aqueous solution, to become more acidic because they are increasing number of the hydrogen ion concentration inside the aqueous solution. Meanwhile, contrast with base, base is a substance that will reduce the hydrogen ion concentration in a solution. Okay, how they can reduce the hydrogen ion concentration in a solution? They reduce it by, they will accept, okay, the base will accept the hydrogen ion in the aqueous solution, such as ammonia. Okay, ammonia acts as a base. When nitrogen unshare electron pair will attract a hydrogen ion from solution, thus creating ammonium. Okay, as you can see here, this is ammonia, okay, and H3. So what will happen? Ammonia will accept hydrogen ion from dissociations of water molecules, and thus it will form an ammonium. Okay, when the ammonia accept the hydrogen ions from the water molecules, what will happen? It will decrease the concentrations of hydrogen ion in the aqueous solution. Okay, therefore, solutions with more OH, okay, and compared to and have a less hydrogen ion are basic solution. Examples of a strong acid and bases. Strong acid example is hydrochloride. Meanwhile, bases, strong bases example are sodium hydroxide. Okay, and then example of weak acid such as the ammonia. Meanwhile, example of weak base carbon sorry examples of weak base is ammonia, and example of weak acid is referred to this one, which is carbonic acid. Okay, this one is terbalik. So in a neutral solution, concentrations of hydrogen ion is about 10 to the power of negative 7 molar. Meanwhile, the hydroxide ion is the concentration is 10 to the power of negative 7, meaning to say they are similar, they have same concentration, thus bring to the equilibrium state of the water. So if you add acid inside the aqueous solution, what will happen? The hydrogen ion concentration will be increased. Okay, so it will cause the decline of the hydroxide ion inside the aqueous solution. So if therefore it will cause the hydrogen ion to increase the concentration with 10 to the power of negative 5 molar, then hydroxide ion will become 10 to the power of negative 9. This will increase by 10 to the power of negative 4. Meanwhile, this will be decreased by 10 to the power of negative 4. Okay? So, the hydroxide ion will be declined because of the additional acids. Okay? So, adding a base will cause the opposite way. Okay? Because base will increase the hydroxide ion concentration, and it will cause the reductions of hydrogen ion concentration. So this is the pH scales where the value of pH will decline. As you can see here, it will decline when the H plus is decreased. When the H plus is increased, meaning to say it become more acidic, and the pH scales will increase. Okay, if the value of the H plus is become lesser. So this one is referred to the solution become more basic. And pH for neutral solution is 7. Meanwhile, acidic solution less than 7. Basic solution pH is more than 7. Okay, and most of the biological fluid have pH range in neutral, which is about 6 to 8. Okay, however, the pH in our stomach can reach to 2 pH 2. Okay, such as the gastric juice. So each of the pH unit actually represent a 10-fold difference in H plus and also hydroxide ion concentration. So next is buffer. So when you put an acid or base inside the water will not reach its equilibrium concentrations of H plus and also hydroxide ion. Therefore, we have one substance that is known as a buffer, where buffer will cause the aqueous solution to maintain its pH. Okay, because the pH, the buffer, they can resist the changes to the pH of the solution when H plus, when the hydrogen ion or hydroxide ion is added into the solution. So if the hydroxide ion, okay, if the hydroxide ion inside the solution is higher, okay, meaning to say the solution is acidic. So when you add the buffer, what will happen? The buffer will accept the hydrogen ion, okay, thus making the solution to become neutral. Similar also when there is a less number of hydrogen ion inside the solution. When the hydrogen ion inside the solution is less, so what will happen? Buffer, okay, will release its hydrogen, will release the hydrogen ion, or they will accept hydroxide ion from the aqueous solution, thus making the pH back to normal. So buffer typically consists of weak acid such as carbonic acid, okay, and carbonic acid, the equilibrium will shift left or right as other metabolic process can add or remove hydrogen ion from the solutions. So I think that's all for today class. Thank you.